This episode is brought to you by the Music for Scientists album, now available on all streaming services. Check the link in the description to watch the music video for the song The Idea. Just under a century ago, we learned that the universe is expanding, and by rewinding that expansion, we learned that reality as we know it had a beginning. Astronomers refer to it as the Big Bang. But although that is an awesome name, it can also be kind of misleading. The Big Bang makes it sound like there was a big explosion in one particular spot. So then, if that's the case, where did it happen? Well, this is the thing. The Big Bang happened everywhere. According to this theory, nearly 14 billion years ago, all of space began expanding in every direction at once. Then, some of that energy got converted into matter, which eventually coalesced into stars and planets and other wonderful things like dogs. Now, when we talk about this, the image that comes to mind is that of a baby universe starting as a teeny tiny ball of light, which then explodes out into some kind of space that already exists. But that's not the story, although it is way easier to picture. In reality, all of space is expanding into nothing. It's just expanding. There is no central point where everything began. It's more like all of space just started out small and space itself has been expanding ever since. So maybe it will help to talk about how we know this. Well, some of the evidence that tells us the Big Bang happened also tells us what it was like. For instance, what really sealed the deal on the idea of the Big Bang at all was the discovery of cosmic microwave background radiation. Basically, according to the Big Bang theory, some energy left over from our baby universe would spend the rest of time radiating throughout space in the form of light. The expansion of space would stretch those light waves out well beyond the visible range, but they would still be out there. And we detected that radiation back in 1965. It was a kind of radio static that just couldn't be filtered out, and it came from every direction in the sky. That cosmic microwave background is called the CMB for short. It dates back to around 380,000 years after the Big Bang, because before that time, it was so hot that the universe was opaque. And besides backing up the fact that the Big Bang happened, the CMB also proves that it happened everywhere. See, some of the most recent images come from the ESA's Planck mission. And while there are some spots in the CMB that are a tiny bit cooler and a tiny bit warmer, overall, the CMB is isotropic. That means that it looks the same no matter where you point your telescope. It also appears to be homogeneous, as far as we can tell. In other words, the picture of the CMB would look the same whether you're taking it from the Milky Way or the Andromeda Galaxy or any other galaxy in the universe, no matter what direction you're pointing your telescope in. If the Big Bang happened in one spot and somehow spread out into space that already existed, the CMB wouldn't look as uniform as it does. Instead, there might be hotter and colder spots that would point to a more specific location where everything began. But the CMB isn't our only line of evidence here. We can also see isotropy in the universe by mapping much younger structures, like galaxies. On cosmic scales of 1 billion light years or so, they look uniformly spread out in every direction. When you zoom in, you see a web-like structure which exists because matter likes to gravitationally affect other matter instead of distributing itself evenly across the cosmos. But when we measure these galaxies' trajectories, nearly everything appears to be flying away from us, which is either a very lucky coincidence, or it means that every other vantage point is seeing the same thing. The classic analogy people use to explain this is an expanding balloon. From one point on the surface of the balloon, it looks like the rest of the balloon is moving away from you equally in every direction, but that's also true from every other point on the balloon too. There is no official center. Everything is just expanding. And that's what the Big Bang Theory necessitates, a universe that's expanding outward in every direction. Of course, there are a few exceptions where the pull of gravity can overcome the expansion. Like the Andromeda Galaxy is close enough to us that it's scheduled to collide with us in the future. It's also worth noting that the whole discussion is limited by our solitary view of the universe. Because of the finite speed of light and the limited life of the universe, we can only see so much from the Earth. We don't have technology that would allow us to go to another galaxy and confirm that that view of the universe also looks isotropic and homogeneous. So when we say that the Big Bang happened everywhere, we can only base that theory on the part of the universe that we can see. But given what we've been able to discover so far, well, if you want to say that you're the center of the universe, go right ahead. You just have to recognize that everyone else is too. If you enjoy exploring questions like this, you might like the album Music for Scientists, specifically one track called The Idea. Like the rest of the album, it was written and recorded by Patrick Olson as a tribute to scientists and science communicators, but this song in particular touches on how difficult it is to form correct ideas. It's also pretty catchy and has a fascinating music video, which was created using a mix of paintings and machine learning. If you want to check it out, you can click the link below to see the video or stream the album on all major music services.